Okay, so hi everybody. My name is Sharon Rosenberg with Fortelix, active participant here at the OpenScenario 2.0 working group, mainly involving covering the success criteria, usage and pragmatics, and helping out with the domain model. And I got the honor to introduce to you the ASAM OpenScenario V2.0.0. I'm going to call it OpenScenario 2.0 just for to be short. And we're gonna talk about taming infinity and the infinite amount of scenario space, and we very excited about this standard and think it's a major ingredient in moving the industry forward. So yeah, not going into too many details, we're just going to capture the concept and what's unique about this. So yeah, repeating, I think, some of the messages. What is OpenScenario V2.0.0? So it's a domain-specific language, so we tailor that, we design that specifically for the verification and validation, scenario-based testing, and it has a domain model. These are ready-made, predefined structs, actions, and actors, which we're going to cover in a second what it means, but you get a lot of free stuff that is going to be very helpful for you. And you'll see the language itself. It's declarative. You just say what you want. There's not a lot of lines of code. You don't need a source level debugger to understand what it means. And we believe that even non-programmers can read and understand that. So declarative, short, and readable. And enable automation for all verification needs. So this is about scenarios. What exactly do I want to execute? But it's also about coverage. How do I measure what was executed? If all my goals were met, and even checking. There's some errors at that very high level of abstraction that I encounter. So it's really broad in the scope. Within our discussion, we leverage a lot of the industry knowledge, including Ben mentioned that discussing OpenSCENARIO 1.0, took many of the good things that were there, added things or slightly changed when it made sense. But basically, there's a lot of knowledge and a lot of good things we took from OpenSCENARIO 1.0, and we made that in a way that if you have OpenSCENARIO 1.0, 1.x code, you will be able to translate that, and we'll touch that just a little bit later on. Standard input format, crossing vendors and tools. This entire project is collaboration of a lot of users and vendors and multiple perspectives. And I think we have a good result, a good coherent solution. It's allow composition and reuse, and we'll talk about that, why this very desired language feature was not so trivial to achieve, and we actually achieved that. And support a level of abstraction. Ben touched that. I'm going to go a little bit more into details and demos. Let's talk about the value, the potential value of OpenSCENARIO 2.0. So OpenSCENARIO 2.0 is the language and the domain model, right? You get the standard, but then you need to be building tools on top. And this is some of the value that we could see at this point. So we're going to talk a lot about abstraction, and abstractions allows and enables automation. So we're actually capturing scenario intent in a formal way. You can, like a cut-in. What is a cut-in? You start on the side lane behind and you finish up front on the same lane. That is a cut-in. The language allows you to describe exactly what I said with minimal amount of information, but in a way that is readable for technology. And the technology can do multiple things with that. And that's what we're going to discuss. The technology could actually take and do that cutting in multiple locations and conditions and combine that with other scenario, automatically adjust that to other needs. So we're going to talk about that. Abstraction is a big thing. The other value is measurability. So, okay, I can use abstraction and now the technology can complete what I want in multiple ways. But how do I know that actually all my goals were met? And where am I within the process of doing the VNV? So we have features for that. You can set goals and be very specific with the goals you need on top of the abstract scenario itself. Readability, use modern syntax. Pierre is going to discuss that later today. I'm going to show a few snippets of code, but very readable both for human and for machine. So that is coming. The standard which we mentioned, cross-industry, and that you can translate and transfer code. Finding the unknowns, we use random and stochastic approaches. So this is a key requirement out there. Okay, so I can systematically and productively get what I wanted, but what about the things I didn't think of? So there's a lot in the language itself that address that need. Optimization, and again, we're talking about potential, right? So if technology can understand what's the abstract scenario, and I can express my goals as well, there's potential optimization that could, just go and address what I'm interested with, or put more focus on that. So I may do an analysis on a crossroad and say, what are the key or risky areas or condition, and now let the technology go and deal with that and find more of that. And reuse. And so reuse, use modern software engineering capabilities, but also we design quite a lot that is unique to our problem, to the automotive industry, that, it's specific design patterns that are defined and tailored for our challenge. So you'll see much of that with a lot of focus on ease of use. And of course, these things are platform agnostic, so you can port things from hill to seal, street driving, etc. All of these have application for OpenSCENARIO 2.0. Just to say, this is potential value. So OpenSCENARIO 2.0 does not force nor dictate a methodology or a technology. It's an input format. There's going to be multiple solutions. Here are some things we know, or some things we've seen, and there's going to be more, maybe things we don't think of right now. So this is an input format, and the industry is going to work with it and take it to multiple areas, all based on that standard input format. Okay, so this is what we're going to discuss today. We're going to talk about the fundamental of OpenSCENARIO 2.0, just to get you acquainted with that. Not a deep training, but you will understand the basics after this one. We're going to talk about automation and reuse, where is the value and how it can be added, setting and achieving goals. How do I set goals, take all my concerns, all my risks, and write them down in OpenSCENARIO 2.0 code. I'm going to talk a little bit about how to learn more and summarize at the end. So let's start with the fundamentals. And my assumption, by the way, I cannot see questions if there are any questions. So maybe we should take this at the end, but Ben, I leave it up to you to decide. Okay, so it's a world made of actors, the OpenSCENARIO 2.0 world. Actors are abstract entities that make up our world. It could be vehicle, pedestrians, they're going to have attributes. So a vehicle, that is an actor. A traffic light, a cone is an actor as well. It's going to be participating in our scenario. And here's a person, which is also an actor. Even the environment is an actor. So you can have weather or time of day. This is attributes of the environment actor. There are built-in actors in OpenSCENARIO 2.0 domain model. I'm going to mention that. We spend a lot of time thinking what would be generic enough and usable for multiple circumstances, and this is the domain model. Here's an example starting from scratch of an actor, of a person actor. So you can see the keyword is actor, and it's a person, and we have a gender, which could be a male and a female. You can define whatever enumerated type you want, give it whatever values, and it could have also a numeric value. So here's our person, which could be a male or female. The age group could be child and adult. And here's the age, which is UN. And here, the first time we're going to see constraint or dependencies. We want to define what is a legal person. So we put a constraint of age smaller than 120 years. And we're saying here that if the age group is a child, then the age is smaller than 12. So these are kind of dependencies that would make a legal person definition. And we'll explain more how this is helpful, extremely helpful later on for scenarios that we're going to write. But this will generate a person, female, child of age 11, or a male adult of age 92. Now, you're not going to get a child of age 92. That wouldn't make any sense. And if you want a machine to generate persons for you, many kinds of persons, you need to have these constraints so the machine will understand what is a person, what are the dependencies between those attributes. And this is where the constraint or dependencies are so useful, and we'll see more examples of that coming up. So we use the Python indentation to indicate the block of code. Randomization and stochastic approaches, we kind of saw how we can randomize a person. At least you'll see how we randomize vehicles and their behavior and still make that consistent with the rest of scenario, with the scenario intent that you as a user had in mind. So this is with that. Here comes the actions. The actions are actually implementation agnostic pieces of behaviors that are associated with actors. So if we just look over here, so a vehicle can drive, the pedestrian can walk, an actor, sorry, the street light can turn red, and a cone, you can assign position to a cone. It's a passive thing, but you can still assign position. That's why we're saying associating that. And this is going to be a building block for our scenarios, which are coming later on. This is how it looks in code. So this is our actor, and we still have the gender and the age group, and you can see that our action is walk, and you can walk in different speeds. So here is the speed of type speed. This is the field definition, and this is the type. And you can put constraint on that, you know, whatever speed makes sense or reasonable. So when I generate a walk, I want my person to walk, it will have some default speed that makes sense. We'll see later how this will be adjusted if I put that walk within a larger scenario. You will get constraint from the scenario itself to ensure that the speed is coordinated with what I'm trying to achieve in the scenario. So we'll see that later on. But by default, all these attributes or fields are randomized. They're going to be randomized, and if you don't have any constraint on them, it's going to be the default type constraint that is generated. So for enumerated type, it's going to be one of the values here. So let's continue with that. Yeah, in this webinar, most of the thing will be from the normative domain model. And we're building our way up to scenarios. So here are scenarios. Scenarios are basically composite of actions and other scenarios. They capture behavior over time using timing directives and control flow. And you'll see that they're very short and concise. Scenarios are modular and can be combined as building blocks. They are named entity. You give a name to them, and we always, as opposed to create some very complicated or sophisticated scenario on the top, we recommend combining the logic within a reusable scenario and then build on top of that, because you may want that scenario to be a sub-scenario of a more abstract scenario. So scenario is the key for everything. Scenario definition is broad. So it may contain the actors, like the vehicles, stationary object, ODDs. weather, what kind of roads am I driving, location, all of that is important part of the scenario and it's absolutely part of the scope of OpenSCENARIO 2.0. Ben kind of mentioned that the domain model is extendable. So you can extend and enhance and create any attribute you need, both in terms of actors and actions. All of these are user defined. So you need any kind of HMI actions, buttons to be pushed, or levers to be pulled. You can define those, and it's absolutely flexible for your convenience. So here's an example of a cutting. We have the scenario that you see here. That's the keyword, and cutting is the name. And here's the cutting side, because cutting can happen from the left or from the right. So this is one attribute. Here's the road. Note that we do mention location, and I can be concrete if I want about the location, but you can also be abstract about the location. So what we're saying here, here's my road of type road, and the only thing I care about in the cutting that there will be at least 2 lanes. This is what we're saying right here. So we provide some directives about the location, but we still keep that abstract. And I hope that it is clear where we're going with this, right? I want to take this cutting and running on multiple locations on the same map, or running on multiple maps. And as long as the location of more than 2 lanes, that location will be valid and relevant for this cut-in. And technology could just take that and run it with whatever location is legal for the cut-in. Here's our behavior block. So the behavior block, this is the real activity over time. This is where it's being described. So what we see here is serial, and you can do things in serial or parallel to one another. This is a cut-in. So we're getting ahead, and can read that get ahead phase is in parallel. The SUT is going to drive, and car 1 is going to start behind, 5 to 100 meters behind the SUT, and then it's going to end 5 to 15 meters ahead of the SUT. At the end, this is what you see here. And then the next phase is the change lane. So the SUT is still going to drive, and car 1, that's the other car, is going to do to start at the side of the SUT and finish the same lane of the SUT. That at the end. So you can pretty much read that as English once you get used to it. So yeah, use timing directives like parallel and serial. This is the get ahead phase, and you can describe those phases. And these phases, you see, these are labels, but you can actually, and we're going to talk about it just a little bit today, you can actually put constraint from above to make this cutting different, to adjust it or steer it for some corner case that you may have. So this get ahead is actually, I can use that to say, well, I want the get ahead phase to finish sooner than later, or interact with sub drive within the get ahead. So these labels that are part of the language would help you refine things as needed to nail some corner case or edge case that you may need. So, and we're using constraint. Was there a question? Okay. And these what you're seeing here, these are modifiers. So it's look like imperative code, but it's actually all these actions, and these are really constraints on top of things. And they like that they're additive. You can put more and more constraint on top. So we just wrap them in modifier for simple. Sorry? Is there, maybe someone needs to mute? Okay. So this is just our first example of scenario. The way it works with the scenario, these attributes are being randomized, and then the behavior is based on whatever is randomized. So that's how scenarios are work. You also, the attributes of scenarios are being randomized, and then the behavior is running. Okay, so let's this was just the beginning, touching a little bit about the OpenSCENARIO 2.0 layered approach. So like we said, we have the language itself. This is where you can define structs and actors and actions. The pieces of code we've seen were starting from scratch. But we also provide the domain model. The domain model are ready-made classes. We invested a lot of work to make sure that these are generic and you can get a lot of the things, not everything, but a lot of the things that are frequently needed out there can be satisfied by the domain model, as well as saving you time for defining those. These allow composition and reuse. So if you use, for example, our person or our vehicle, and someone else without any upfront planning was also using vehicle and person, you can compose these scenarios and put constraints and coordinate the activity of both. So this is very critical for reuse, the domain model itself. And like we said before, you can always extend that, and we believe we will also go and add more and more things as we see them right. So these are the two things that you're getting from ASAM. And now you can build things. So we mentioned the reusable content. That is one layer that you can build on top. So you can take an expert for ACC, for example, and you can create a lot of reusable scenarios that are valid for the ACC function. He's an expert with that. He's going to create a lot of scenarios, really thoroughly verifying the ACC function, and that could be used in multiple projects, right? So that is the first layer. But then you can layer constraint on top, because I'm going to try things on different ODDs, on edge cases, project-specific need you can add on top. So you can always layer another constraint on top of things. The assumption is that, yeah, there's something you can go ahead and run it, but you can always further steer it to whatever project, ODD, test requirements you may have. You can always steer and add more constraint on top. So this is how this hierarchy works. Again, like we said, this all reuse and you know, this is using also object-oriented, which is a classic computer science reuse, but there's much more we put on top. And the idea is to have a few experts enable and help multiple others, which are just going to create edge cases, debug them, maybe add coverage, etc. So this is the layered approach in very quick 5-minute speech. So let's talk about the layers of abstraction, which Ben has mentioned. And yes, indeed, we chose to stay consistent with what Pegasus is using out there. So here's the 4 layers of abstraction. I'm going to show a little bit of code snippets for each and every one. So concrete is where all the attributes are specified. Like we have the actors and the actions, and remember, all of them, and the scenarios, all of them have attributes. Well, if I concretize, if I specify all of them, they become concrete. Now, you can also go to the level of trajectory level concrete. Trajectory level concrete is not all the attributes are specified, but now I'm really specifying for each actor where exactly it's going to be at every point of time. So we allow that as well. But this is concrete scenario, fully specified. These are logical scenarios. The OpenSCENARIO 2.1.0 is working on that area. You know, you have a concrete location, but you have ranges. These are fully specified ranges. There's no dependencies between them, but really that makes up a space. And now, as opposed to just create concrete scenarios, I can span spaces. So that is logical scenarios. Here are the abstract scenarios, and here's where, if there are any dependencies between the actions, if you want to change location and you want the scenario to adjust to a specific location, this is where abstract shines. So the intent is specified in a formal description within the scenario itself. Okay, so all the dependencies are captured, and now machine can go in and do a lot of things with it that typically we need an engineer for that. So it's also span spaces, but now the dependencies are specified, and a machine can do the cognitive work that typically engineer needs to do. And there is the functional level, which is full natural language without a formal description. So this could be diagrams, and this could be intuition and multiple things that are not formal for a machine to be read. So OpenSCENARIO 2.0 involved with all of these. It can do all of that, and obviously the big thing is with the abstract, with the level of abstraction. So all of these, by the way, are usable and essential for your project. So sometimes you want to go manual with a specific starting point. Some people start verification with more narrow scope, and then they're going to broaden as they're doing validation. So this is where you get to scale, find the unknown. This is where reuse is, right? Because if I hard code a scenario to a location and I want to run another scenario that is hard coded to a different location, that would not work, right? Unlikely that I'm going to get anything useful out of that. So the fact that you're abstract, it means that OpenSCENARIO 2.0 technology can combine these scenarios, decide where they're going to run, and run them like that. So let's look at a few examples of code, get acquainted with that as well. So here's a concrete scenario, some concrete scenario. And you can see, I'm not going to read through the code, but everything is fully specified. That's the main thing here. Every attribute is selected with one value, and that is the value that I'm looking for. And the location is fully specified as well. So they're specific, they're accurate. They could be time consuming to develop, right? Because there's a lot of dependencies, and even just the simple dependency of speed times time equal distance, right? If I don't select the right thing, if I don't take into account the maximum acceleration, the segment size, etc., I could get something that is invalid, and then I'll have to retry till I get what I want. The application for this is developer may start from something very simple, very concrete. That's the right way of doing it, and they may choose some very concrete values. Collisions or real-life starting points could be concrete. Just I want to do exactly, even to the level of trajectory that we've mentioned before. A random result can create unique combination. So I go abstract, and now I would like to take the concrete and rerun that or preserve that in my test suite. So this is where concrete is useful. Moving to logical scenarios. So this is almost exactly the same, but now as opposed to equal a single value, I can put some kind of range. It can only be literal range, and basically a technology can traverse through the ranges and create all the scenarios. So it's a family of scenarios, and now we're covering spaces. So this is useful, but there's a lot of combinations of speed, acceleration, location that are invalid, right? Can we have a technology or an engine that will basically find only the legal things, only the interesting things? Can I define what is interesting? And this is where abstract shines. You basically have full expressiveness to define whatever you want, whatever Boolean expression you want, whatever dependencies between actors, actions, timing, all of that can be fully captured. Whatever your intent is, you can capture that in a formal way that the machine will understand. So let's look at this example in here. This is a right-cut-in emergency vehicle, and here's my emergency vehicle. Now, the emergency vehicle is abstract, right? Because there could be multiple types. So it could be that I'm a motorbike, sedan, a van, or a truck. These are all types of emergency vehicles. And you can use that in abstract. You can just create a hierarchy of types or of different emergency vehicle kind, and it will just select some emergency vehicle, and then it's going to behave like a truck or like a motorcycle or like whatever was chosen, right? So you can create, well, I want to cut in emergency vehicle and I want to support all the emergency vehicles. That's the right way of doing it. This is the location. It's not concrete anymore. We mentioned that. And there's a lot of attributes you can add, and you can describe the topology of the road in OpenSCENARIO 2.0, etc. So it could be, no, I want to run it on urban, rural, highway, whatever it is. But it has to have 2 lanes. That's the way to write it. And you can say, well, I want only urban as well. It could be here, or it could be layered on top for a specific edge case that you may need. And this is the behavior that we see in here. And look, you can even say, well, I want it to be on the right. And there's a lot of implications of what needs to happen to have a cut-in on the right versus on the left. So you need to have 2 lanes, but the lane on the right need to be empty for the cut-in, for the other cut-in car to come. So there's a lot of implications here that is being done by technology, and this is what we're looking for that level of automation, as opposed to a person plan the scenario for a specific location, enable a technology, oops, this is running on its own, enable the technology to jump in and do the right thing, and we'll just sit there on the virtual driver's seat and just say what you want. Yeah, there's a lot of implications. Segment size, max speed, things need to be tuned accordingly, and the language now capture all these things. Okay, this is just an example of composition. So here's some vehicle, and it could be any traffic vehicle. And now in parallel, I want to do the right cutting that we've seen in the previous example. And I want my traffic participant to cross the road. Here it is. And one of snowstorm, mechanical failure, etc. So you can really, this shows a little bit of control flow, how you can do one of multiple things. Now this, I hope it's not going to continue to run, but this is an enablement of really ODD agnostic content, right? Because now I can create content that is not attached to a specific location or a specific map. I can combine things. Let's create an ecosystem around it of maybe companies creating this kind of traffic. So this is a big thing. And there's some recommendation where it makes sense, because we mentioned that sometimes you want to do concrete or logical is enough. But the expected value of writing abstract is automation scale, searching the unknown. It's going to get some values, and you'll get some scenarios you didn't think of on different locations, different conditions, and it's all reusable. So that is the 4th level of abstract scenario, and we're kind of done with this, with the fundamental, and I'm going to continue to automation and reuse. You breathe a little bit. So, kind of mentioned that, but I'm going to repeat it again. So now you can, for productivity reasons and for exploring the unknown, you basically describe, using OpenSCENARIO 2.0, what is a cut-in scenario. Just mention the things that are essential, distill the essence of cut-in scenario, and that's what you're going to write down in a very short description and deliver that to the OpenSCENARIO tool. And now you can ask it, well, create an aggressive one with a very low distance, high speed cut-in, or next to a junction, or a specific distance and relative speed. And the machinery is going to digest that, understand what is a cut-in, and create the things you wanted, the variations you wanted, replacing, you or maybe an army of test writers that will have to do that. The idea is to get more out of every test writer that is creating scenarios. And so yeah, the massive amount of scenarios and addressing the unknown at the same time. Just maybe giving one more example of abstract scenarios in a very sometimes small example could deliver the point. So assume that you have this kind of requirement. Ahead and stop, that's the requirement. I want to check that no collision occurs as you drive the ego to some location. The NPC arrives at the location 0.5 seconds ahead of the ego and stop. So that's, someone thought this is very important scenario and I need to try that. If I go without abstract scenario, well, I'll have to select, a location on the map, estimate the ego speed and the NPC starting point, speed and location, and try to coordinate the 0.5 seconds ahead of the ego. Try to coordinate that. And then I'm going to program or draw that and check if my calculations were okay. And if the one are not okay, I will be smarter enough to move them a little bit or change the speed a little bit so I'll get what I want. And this kind of effort is needed per run and may require maintenance in the future if the self-driving car is driving in different speeds or taking different decisions now. So that is what you get without abstract. But this is just a direct translation of what we need to achieve. So here's the head of stop scenario. We're just writing what is needed in OpenSCENARIO 2.0. So here's the translation. Doing parallel, the SUT car is going to drive. By the way, many times you're just going to say the SUT car to drive because you want to be SAE level agnostic. So, whether it's level 2, 3, or 4, this will work. So you'll see that in many of the scenarios, we just tell the SUT to drive. In some higher automation level, we have less control. So SUT car is driving, and in parallel scenarios, car number 1 is going to be at position 0.5 seconds ahead of the SUT car at the end. And after that, we're just going to drive in speed 0, which means stop. The technology now could, in OpenSCENARIO 2.0, could select a random location, with whatever map you're going to deliver it. It's not hard-coded or locked to any map. Calculate the initial locations and the right speed. Report if this scenario truly took place or not. There is enough semantic in this description to tell you, yes, I was able to achieve it or not. This is where the monitor kicks in. But the language, the way it is described here, it's enough for technology to decide, yes, I was achieving that, I was able to achieve that, this scenario as specified really took place, or no, I failed in creating the scenario. Maybe the SUT changed lane or changed its pace or speed in a way that I couldn't accommodate in runtime. So you can actually report what took place and what not. So this is just an example of one step, and scenario could be of multiple phases, but to show you what kind of coordination this language can allow you to achieve and what kind of automation. And these scenarios will be adaptable to whatever software or specification changes. So yeah, look at the length of this. You get used to it. I don't know if you've seen it for the first time, what you think, but once you get used to it, it's very easy to understand and read and achieve. From this one, right? I can achieve as many as I want scenarios. So this is just about that. Let's talk a little bit about reuse. The VNV task introduced actually an extreme reuse challenge, much more than what computer science was dealing with. Each scenario is a target product to explore a different risk. I may create a different scenario for a specific edge case with a little bit of modification. And that's the thing I want to run right now. And I may create many of these on a daily basis. Well, here's something else. Here's a different variant that I want. Here's a different map or a different location. Try with that. So the entire decision making and what you factor in and out is different. And So we are actually adopting some of traditional object-oriented. We use that, and you're going to see that a lot, but we also introduce other powerful core capabilities specific for these kind of challenges that, some of them are being used with other languages, some of them are really unique to what we're trying to achieve. And a lot of focus was spent on ease of use. And, there's a lot, if you're going to become an expert in object-oriented and design patterns, you know how complex they are. We kept things very easy to use, and I hope when you look at it, you'll see it. So some of the key reuse capabilities of the language is usage of constraint. This is actually reuse, because constraints are just narrowing or just setting some boundaries, but you can always layer constraint on top. So there's no end to that, right? Unless there was a very specific value that you chose. You can further steer it the more and more you need to. So the additive nature is constraint is one thing. The object-oriented, we mentioned that. That is something we support. There is the aspect-oriented programming. Aspect-oriented programming allows you to extend things without introducing a new type to the system. So let's say you want the cutting scenario in all the scenarios to behave differently than what it was doing before. Now, remember, this cutting scenario is being invoked and triggered in multiple other scenarios. What you can do is actually extend the cutting scenario to just happen in specific speed or location. 3 lines of code, that's what it is. And now all the scenarios will behave as you want to. Wherever it's being invoked randomly or explicitly called by a different scenario, now it's going to do what you want. Very easy to use, very powerful and flexible. There's conditional inheritance as well. I'm not going to go too much into details of that, but extremely useful as well. This is where I can generate a vehicle to be whatever I want, and I can even control how many trucks versus sedans versus motorbikes exist I can do that kind on top of a type hierarchy, and this is something that object-oriented programming does not support very well, and we have a very elegant solution for that. I would not go into details. I just want to show you that these are the things we've touched. So this is just an example of an extension, and I'm not going to read through all of that, but here's some cutting scenario with a little bit more meat in it. So you see the attributes of the scenario, and I have some duration here and speed. I factored out a few parameters that I think are more frequently needed and used for a cutting scenario. And here's my do block, the behavior, the change lane phase with some drives in here. And that could be one file. And then with the different, very short extension, I can come and say, well, I want this cut in. I want it to happen from the right, and I want the change duration to be 2.4 seconds. This would be just a small extension on top of this scenario cut in. And now I can run just this cut in or run multiple scenarios that eventually will call a cut in. It will be exactly as I want to. By the way, I can create type constraints and I can create specific instance constraints. I'm not going to go into that, but you have full flexibility to create both generic constraint that will influence all the cuttings or just influence a specific cutting. This is all acceptable. So this is just an example of aspect-oriented, and I hope you can see that there's not much you need to learn beyond the fact that everything is flexible. You can even extend enumerated type, you can add more on coverage, etc. So that is about that. And let's talk about setting and achieving goals. What we want to do, so we have these tornets and we have these abstract scenarios, and we can generate many scenarios based on that, and machine can do it, which is great. It could surprise us in multiple ways, create location and condition we didn't think of. But I have some concerns and I have some risks that I really want to ensure that I did that. So beyond the beyond getting the unknowns, well, what about my real risk, the kind of I got from my engineer, from my own gut feeling, knowing the sensitivity of the sensors and the systems that I have? How do I make sure that I tried all of those? Should I now go and create directed? And the answer is no. Just create the coverage for that. So you can actually create coverage goals. These are the things I want to cover. And now, when you run things, by the way, this is just to reflect the fact that you can start very narrow, going after your coverage metrics, maybe, you know, as initial development stages or doing verification. And when you go to validation, you grow. But you go with very narrow scenarios. We also support KPI monitoring and self-checking in OpenSCENARIO 2.0. This is critical, right? Because if I'm creating a lot of scenarios and the scenarios I'm creating are going to impact what kind of checking I'm looking for. Like, just to give an example, 0.5 seconds TTC could be great because you just in a heroic way, my autonomous vehicle saved the day and was able to avoid an accident, or it could be for no reason, it came too close to a person or a vehicle next to it. So a lot of times the context impact our monitoring and checking. Is this a malfunction? Is this incorrect? Or it's not? That is great, actually. So the language support also self-checking. And I can look at the aggregated result of where I am. So here's some dashboard. I can look at a lot of tests and I'll see, based on my goals, this is where you are. These are the things you haven't done yet. And now you can further steer things. You know, remember, constraints are additive. I can steer it towards areas I haven't tried or some locations that I want to try. And I can adjust my goals based on what happened. Maybe I find failures that make me think, well, I need to explore these kind of junctions and circumstances more. And so this is where you can layer more constraint and steer things where you want to go. And this is just, you know, you start narrow, you expand the ODD. So you basically, what you're doing here is you describe your goals and then you work in a systematic way to achieve that. And there's also the random that is going to select things for you. This is a very powerful combination when you use coverage to drive your verification. That kind of a process. Here's a little bit more, you know, on the conceptual level. So we want to combine chaos and order for targeting knowns and unknowns. If you look at the coverage metrics, this is where the order is. Everything I plan for, everything I care about is there. It's an organized map of my concerns and risk dimensions. It's gradable, so objective goals, it's going to be automatically accumulated for me and presented. Here's what you've tried from observed data, right? Not the input. And I can create reports, I can create milestones, see where I am versus those milestones, etc. And there is the constraint random part. This is where the random exists. So unknowns, surprises, unexpected. And how we get this combination working for us. We can see that whatever we thought of, whatever is concerned, we met, but we get there in unknown, surprising way to try the unknown and get more variety of scenarios, you know, not just repeating the same pattern. Just a comment here, the constraint random is not Monte Carlo, right? We're talking about steerable control random. So this is kind of about that, and here how it looks like in code. So it's just cover definitions. You can find it in the LRM itself. So the main things are what do I want to sample, what do I care about, and when do I want to sample, because you know the values are going to be changed over time, obviously. So what you want to sample, at what time, this will be collected and eventually aggregated and reviewed on a full test suite level. So this is how it look like. We extend the cut-in or the cut-in and slow scenario, and we're saying, look, I want to try on both sides. That's how you write it. Just one line of code, cover, side, and sample it at the end of the cut-in and slow. So just sample the side. This means that I care about both left and right. If I didn't care about left and right, I have a very simple way to say, ignore the left. I just care about 5 cut-ins from the right. I can do that. I can be as precise as I want. We're defining the goals. I can cover the car kind, and then I can say, well, I care about the combination of both size and car kind. So I can have multi-dimension kind of definition that I want to have crosses. And I can say, well, I don't care about the entire cross. There's things I don't care about. And this is a little bit more sophisticated coverage definition, and then expressing what I want. So I want to sample the speed, that is here. Sample the speed at the change lane, whenever the change lane ends. See these labels? They're usable here. I'm using them. Well, go to that event. This is the event. When the change lane ends, I want to capture the speed. And now I care about the speeds. Now, speed is the continuous values. I can have between 0 to between 10 and 20, there is infinite amount of speed. But I don't care about each and every possible speed. I shouldn't. But I care about representation of 10 to 20, 20 to 30, 30 to 40, and so on. Very easy way to do that. And this is how we sort of grade infinity, right? We create buckets. This is what is being described here in the coverage. The range is 10 to 130, but I want to sample, I want buckets of 10 kilometers per hour. So it's 10 to 20. This is going to create 10 to 20, 20 to 30, 30 to 40, etc. And it's enough in this one. I'm just saying I need one representation of the 10 to 20, 20 to 30, 30 to 40, and so on. This is what I need. This is my goals. Yes, I know there's ways. I care about this more than that, and disable collection of coverage, etc. Coverage should accurately represent your goals. Just to say one thing about that versus constraint. Constraint will prevent something from happening. Coverage is, this is what I care about, and these are different things, because sometimes I don't care about cutting from the left, but I wouldn't prevent that, because now I'm going to get more interesting occurrences going, execution going. So I'm not going to prevent it with a constraint, but I'm just not going to put it as part of my coverage because I don't care about that. So this is how to take coverage and constraint, and this is how they complement one in another. Again, a very key problem out there, right? Knowing when you're done. When am I done? It's just miles. Miles are not good enough. This is really tell what functions was running, what maneuvers were running, and how they were running. Were they running enough in different ways that I care about? This description that we have in here, we haven't touched that, but scenarios that you read, they could be actively creating the scenario, right? Triggering the scenario in a way it is specified in the cut-in and slow scenario. I want to start like this, so let me force that behavior on a seal device or a hill device to do what I want. But there is let me just observe some occurrences, some situations, and identify, did a cut-in and slow happen in that situation? Did it happen from the left or from the right? What kind of car or vehicles were involved? So this is actually a passive description as well, both the scenario and the coverage. So I can run things in whatever platform, seal, hill, test driving, proven ground, whatever it is, and run the logs against these OpenSCENARIO 2.0 definition and create reporting that here's the things you've tried on test driving, on seal. You can coordinate and correlate things. Here's where you didn't drive enough. There's some goals that you're probably not going to try in real life. You're not going to make a key jump behind the car and see if the if the vehicle stops in time. This is where you want the virtual to work. But now you have the tools to define and reach your goals with the right proper execution platform. So this is about coverage, and we're almost done. How can you learn more? So we put inside the LRM itself, we put some methodology guidelines and some reading materials that might be interesting for you. So I just took a few snapshots here. So there's writing open scenarios, and there's some guidelines and codes, and we're building your knowledge up. This is sort of a tutorial, and there is key terminology and conceptual overview, etc. So you can go ahead, and there's some best practices as well. So how do you write reusable scenarios? If you use a specific style, for example, if the ranges that you allow to some attributes is very narrow, then these scenarios are not going to be usable for edge cases. So you might want to put default constraint which allows preferences and these kind of things. So there's a lot of good tips like that, how to make your scenario reusable, how to format your code, how to extend the domain model. Assume that you have an HMI, right? You have your own button that you only support, that and no one else, and now they try. Just to mention, there's vendors that are participating, are also providing technology and training. PMCF, IT Consulting, they provide a Python-based framework. You're going to hear more about that. We're holding an expert webinar series. If you want to join, these are free of charge. Actually, the next one is this week on the 20th. If you want to join, this is the address. And yeah, join ASAM. There's a lot of very interesting discussion going on and exchange of information and data. And we're up to the summary. OpenSCENARIO 2.0, it's a DSL and domain model for the, this is running for me. So introduces a real revolution in scenario-based testing. The modern user-readable syntax, and Pierre is going to cover more of that. The automation we enable, measurability and coverage, reuse and ODD agnostic content enablement. That's the kind of things you're getting by allowing ranges that are farther steerable from above this, and being agnostic to locations, etc. Joint work of multiple talented, hardworking people that did, night shifts for this on top of their day job to create this cross-industry standard. Like we said before, we recommend reading and providing feedback and participate in the project itself and the implemented forum. You want to see what's there to make sure it's validate your needs, whatever you have. And if there's something fundamental broken, we hope that there's not. We're going to assume that there's not, but still check ourselves. But even if we don't have something that could be, something that is not broken, we want to write these things down so we can take the right decision for the next revision of OpenSCENARIO 2.x, and join us to lead the automotive industry forward. Thank you so much for the time.